Thanks for joining us for this very first session of Practical OSPF for Network Engineers, part of the Net.Academy curriculum. This is actually our first video in a series of videos around OSPF. Hey everyone, Jason from Net.Academy. If you'd like to be notified every time we have new content, please subscribe to the channel and click the little bell icon. That's all it takes. Thanks so much for your support. Just as a reminder, in case you missed our introductory video, we focus less on certifications, more on practical day-to-day network engineering topics. So let's take a look at what we're going to cover today. We're going to go over what's the difference between a link state and a distance vector routing protocol. We're going to talk about the SPF algorithm and some best practices around that. We're going to talk about two specific router roles, the ABR and the ASBR. And then we're going to talk about the two different area types, backbone or single area and multi-area. Okay, let's hop right in. So you probably already know this, but OSPF is designated as a link state protocol. This is as opposed to a distance vector protocol such as EIGRP. Now, there's other protocols, other examples of both these types of protocols. I will just tell you in practical engineering, you're going to find you're mostly using OSPF or EIGRP as your IGP, and then BGP, which is a path vector protocol, as your external routing, right? So we're going to focus on that assumption. What does that mean? Well, that means that each router floods what we call an area with its information. And then a map or a tree can be built based on this flooded information. And I'm simplifying things, but this is at the core of what you really want to understand, right? Is that we're going to build a map or a tree based on this information that gets flooded out of these different networks. This is opposed to a distance vector protocol, which still floods information, but it floods, instead of on an area, it floods to every directly connected neighbor, who then floods that onto its directly connected neighbor. This leads to what we call routing by rumor design, right? And I'm not really here to pick between distance vector or link state. They both have their pros and cons. And I think it's a more worthwhile conversation to have, to ask yourself what properties of each would apply most directly to your particular environment. So both protocols are fine, but there are some differences. Like distance vector, it tends to be a faster routing protocol in terms of convergence, and it tends to be a simpler routing protocol. However, it does so at the cost of not scaling quite as well. Link state tends to be more scalable. However, it's not as simple, nor is it as fast. These are generalities. You can absolutely make a distance vector protocol like EIGRP scalable and complex, for example, right? Or you could take OSPF and make it faster and simpler, for example, by running it in a single area or something like that. I'm just talking in generalities. In general, these are the properties. So if you're in a small network, you probably want to look at something like a distance vector, like EIGRP, which is very, very fast, right? However, if you're going to be in some kind of a scalable network, you probably want to look at something like OSPF, right? Which is going to lead to a much more scalable architecture because OSPF forces a hierarchical design within the network if you're going to get it to function properly. So we talked about this idea of building a tree and putting yourself at the root and then looking up through all the branches, right? And this is exactly what it is. It's actually a term from computer science, right? But anyway, let's take a look at this SPF algorithm. Stands for shortest path first algorithm. It's also called the Dijkstra algorithm. They're used interchangeably. I see in computer science, it's most referred to as Dijkstra. And in networking, I see it mostly called SPF, but the two are interchangeable. It uses something called cost as its metric. So a good example is here on the upper right. R1 to reach a network on R5 has the following costs, right? It could go via R2 with a cost of 180. It could go via R3 with a cost of 60, or it could go via R4 with a cost of 120, right? It's important to understand what composes that cost metric in OSPF. And it is based solely on bandwidth, also called the reference bandwidth. And this comes into our first practical limitation with OSPF. OSPF, for the most part, and this could change depending on your vendor, and it could change depending on the software or the model that you're running. But in general, in OSPF, it is still based off of a reference bandwidth of 100 megabits per second. What does that mean? Well, from a practical standpoint, it means if I have a 100 meg link or a gig link or a 10 gig link or a 40 gig link, they all share the same cost of 1. In general, a lower cost is more desirable. Since I'm dividing everything by the 100 meg reference bandwidth, I can't recognize anything above 100 meg. So my first recommendation to you from a practical standpoint is change this reference bandwidth. Change it to something much higher, right? I would probably do at a minimum 100 gigs. But if you're really looking a little more long term, or if you're in, let's say, a high speed network, like you're doing sound or video editing or something like that, some of the studios we work with do this sort of thing. 100 gig might not be enough. You might want to go up to something in the terabyte range, right? It has the capacity to go much higher, so go ahead and take it much higher. When you do that, you really want to change it across the entire autonomous system so that everyone agrees on the reference bandwidth that the metrics are being sent out as. Otherwise, you may see some instability in the network, particularly perhaps inefficient pathing, right? You might end up taking something. So if you're in a green field, of course, you can just deploy it with the reference bandwidth and make that part of your template. If you're in a brown field, you're going to want to probably change it out at the edges and work your way into the core, right? So just keep that in mind. Let's talk a little bit about router roles. So there's a couple of different types of routers in OSPF. There's something called an area router, there's something called an area border router, and there's something called an autonomous system boundary router. So an area router is really simple. It is a router who all of its OSPF interfaces are in a single area, right? So R1 only has a single interface. That interface is in area 0. That makes it an area router. A special term to note is if all of the interfaces happen to be in area 0, which in R1's case they are, it's also called a backbone router. Those are interchangeable. A backbone router is just a special type of area router. An area border router is a router who has interfaces in at least 2 distinct areas. So in this case, R2 has an interface in area 0 and an interface in area 23. That makes it an area border router. It borders 2 different areas, in this case, area 0 and area 23, right? And we'll talk a little bit later about some of the special capabilities that come with being an ABR. ABRs are going to be very important when we get into area design, probably in a few sessions. And then the last type of router role I want to talk about is the Autonomous System Boundary Router, or ASBR. And this is effectively a router where I redistribute some other route into OSPF. In this case, I have a link on R3 that runs EIGRP over to R4, and that gets redistributed into OSPF. And that makes R3 an ASBR, right? So because it's bringing in these external routes, it's at the boundary of 2 autonomous systems, one for OSPF, one for EIGRP in this case. There's 2 main ways to design at a high level, your OSPF. You could do single area or multi-area. Single area is by far the simplest. That means everything is just an area router. I don't have more than one area. All interfaces are in a single area. If you're going to run single area OSPF, you're probably in a fairly small network. That's okay. I would always recommend, if you're going to do single area, do area 0. This is because, as we mentioned earlier, area 0 is also known as the backbone. That means for any two areas to talk to one another, they have to do so by traversing the backbone. So if I start in single area and I make everything area 0, it allows me to change it later on and still maintain a core area 0 that's contiguous, right? And indeed, areas in general must be contiguous. So please keep that in mind, right? That's pretty easy. In single area, it's single area. You could still have an ASBR in single area OSPF, but you cannot have an ABR. And again, we'll dig into some of the special capabilities of both those types of routers in future sessions. In fact, we'll have a whole session, several sessions from now, on things like redistributing into OSPF and what that means. Also, we'll talk next session about things like stubs and total stubs and not so stubbies. You could still have that sort of thing in a single area, but it might not be as useful, right? It's not very common, I would say. So again, my recommendation here is, if you're going to run OSPF in a single area, you should have a small and simple network for the most part. And you should make that single area area 0 in case sometime in the future you need to expand it out. This is opposed to multiple area OSPF. So OSPF has more than one area. Here you can see it's the exact same drawing as before, and I've kept in area 0 in my backbone, but the link between R2 and R4 is now in area 24, and the link between R1 and R3 is now in area 13, right? You'll note that this makes R1 and R2 ABRs. They're area border routers. They are routers that border two different areas. R1 borders area 0 and area 13. R2 borders area 0 and area 24. This is probably, in my experience, the more common way to run OSPF, but I do have a bias that I want to be upfront about, and that is, I mostly work in enterprise networks. So, companies that have larger networks has been most of my career. And so that's probably partly why I run into so much multi-area OSPF. If you're a small company, single area is fine. There's no problem with single area. When we do run multiple area, it does open up a lot more capabilities. We can do things like route summarizations and so forth. If we go back to the very beginning and we talk about that SPF or Dijkstra algorithm, remember what I said back then. It runs that per area. You will have an SPF tree for area 24, for area 13, and finally for area 0. So you could think of it as it's link state within an area and distance vector between them, because effectively, if I need to go from area 24 to area 13, it doesn't map everything. It just says, oh, just go to your ABR, and your ABR takes care of it, right? Gets up to R2, and that says, how do I get to area 13? I just go to the other ABR, R1, and then R1 has a complete map of area 13 and can get to any of the networks and take the most efficient cost to get there. Otherwise, you're just taking your most efficient cost to get to the ABR. That's an important distinction, and I just wanted to be clear about it. So that's it for this first session. You'll see that these are going to be smaller and bite-sized. My hope is, by doing that, it makes it easier for you to consume it, but also to go back and refer to it again in the future. If you do have any feedback or guidance, please feel free to pop me a line, jbomar@la-networks.com. Thank you so much. Have a great day.
Need help? Call our cybersecurity team and book a consultation with us today.